Alaska is an exciting natural laboratory full of extreme events and hazards. To an earth scientist, an atmospheric scientist, or a space scientist, there's no better place to be to study these events up close and personal. The Geophysical Institute is located in Fairbanks, Alaska. It's part of the University of Alaska Fairbanks. Three important focuses we have at the Geophysical Institute are volcanology, seismology, and space physics.
Alaska Volcano Observatory is a volcano observatory that aims at monitoring all of Alaska's volcanoes. Alaska is by far the most active place in the country when it comes to volcanism. So over the last 40 years, where we have pretty complete records, there have been an average of about 2 eruptions per year around Alaska.
The reason all of the work that we do here is important is that the hazards implications for a volcano erupting in Alaska can extend outside of the boundaries of just Alaska. Alaska is underneath the North Pacific air routes. These are international air routes. They connect, for example, like the West Coast to Asia. And we've estimated recently there are about 30,000 people flying above Alaskan volcanoes every day.
We observe volcanoes and get information about them using a variety of different methods. Once you've got observations that tell you that something is happening, then you have to make some kind of prediction about what's going to happen to the future, and that's where things get a little trickier because you have to go beyond what you can directly observe. So you need to have some physical basis for developing models. So for example, ash tracking models use observations of winds and then, for example, put some particles numerically in a numerical model for the atmosphere and watch how they disperse and where do they go. So that's an ash tracking model, like the PUF model that we use here. So these models allow us to make a prediction of where the ash is going to go after it's erupted.
One of our largest groups and one of the first groups here in the Geophysical Institute was our space physics group. The solar wind connects to the Earth in the Arctic and creates aurora, and currents in the ionosphere can wreak major havoc on satellites, wreck power grids. The Geophysical Institute is well positioned to study these events and provide valuable insights for the nation.
The aurora borealis and australis is charged particles from space impacting the upper atmosphere and creating light. And it just happens when the energetic particles, electrons and protons, strike the atoms and molecules of the upper atmosphere. It excites them. When they get excited, they relax and give off light. And that's the various colors of light tell you what the atomic species are, or molecular species that you're looking at. Society today has become more and more reliant on technology, and that technology is often reliant on satellites or just communication signals that propagate in the atmosphere. And that means that if there is a severe solar disruption, it's going to have a much bigger impact than it ever has in the past.
I work at the Alaska Earthquake Information Center, and what we do here in the state is we collect, analyze, and disseminate earthquake information data.
Well, Alaska has 25,000 earthquakes a year, and three of the top 10 largest earthquakes ever recorded were here in Alaska. So it's a fantastic place to study earthquakes.
We run a very sophisticated network of seismic sensors located all across the state. We have about 400 seismic sensors, and each and every one sends data in real time to our lab here. Within seconds of earthquake, sensor can sense it, sends information here, and we can process that information. And within a couple of minutes, we know where the earthquake is and how big that earthquake is. And if it's a significant earthquake with significant magnitude, and if it's undersea, then we know there is a potential for tsunami.
One of our primary goals here, in addition to doing research, is to train the next generation of geophysicists, atmospheric scientists, and space physicists. We're living global change. So this is the absolute best location to study all these events and to expose students to global change. And as focus shifts to the Arctic in future years, I think you're going to be hearing a lot more from us here at the Geophysical Institute.